so my name is Niels Kramer. I'm the clinical marketing lead for cardiac point of care. And I'm very excited to present to you a group of leaders and hopefully future leaders. Maybe good to note that I have a history with this product. I used to work at Philips, where this system actually is developed. I worked there for 2 years and 6 months. Then the business was closed down. I now work 2 years and 5 months at Siemens, so I don't know what the future holds for us. That being said, currently at Siemens we have the possibility to offer high sensitivity troponin I at the point of care or in the central lab. And I think it depends on your setting and on your preferences and how your workflow is set up, which solution is preferred and which suits your setting best. One of the potential settings as depicted in the slide that could benefit from a point of care based solution is the ambulance. But apart from that, we also think that there is a need for a rapid diagnosis in the emergency department. As you know, there's a universal problem of crowding in the emergency department. Chest pain patients are the second largest group of percenters, but only 1 in 10 actually is experiencing a heart attack. So that means that, and even moreover, 50% or even more is not experiencing something cardiac related at all. So that means that for a large portion of patients, you potentially can rule them out very quickly. And that's also where we believe that a Teleca VTLI or cardiac point of care solution might play a role. So what we offer is a high sensitivity troponin result within 8 minutes. And we believe that that potentially enables the physician to make a decision within one patient interaction. So the system consists of the following components. We have a handheld analyzer with Wi-Fi capabilities. There is a docking station. The docking station itself can be used to charge the system and also can be used to have a cabled internet connection. Then there's the consumable, the cartridge, which can be used with plasma, venous whole blood, and also capillary samples. And we obviously have the ability to hook up to a data manager. So the interesting part, I guess, of this presentation is what kind of performance do we see for this system. If we first focus on the analytical performance, we see that there are 2 important papers, one by Professor Christensen and one by Professor Apple. And if you look at the top here, you see that both conclude that the system meets the designation of a high sensitivity troponin assay. And Professor Christensen has focused on stuff like the detection capabilities, linearity, cross-reactivity, etc. Whereas the study from Professor Apple was really focused on determining our 99 percentiles and also the percentage of measurable healthy individuals. And that has been based on the AACC Universal Sample Bank. Zooming in a little bit on one of the IFCC criteria for a high sensitivity troponin assay, you should be able to measure 50% of healthy individuals at least from your LOD onwards. Our plasma LOD is 1.2, and you can see that based on the Universal Sample Bank, we can measure 80% of females and 87% of males. Our 99 percentiles for females was established at 18 nanograms per liter, and for males at 27. And the beauty, I guess, to a certain extent, is that with the AACC Universal Sample Bank, you can make a comparison between different systems. And I think it's good to note that the Siemens systems, all of them, including the point of care solution, meet the requirements of measuring 50%, both for males and for females. So the other criteria from the IFCC is that you should be able to measure your 99 percentile with a 10% CV or less. You can see here that our LOQ at 10% CV is well below the 99 percentile, both in whole blood but also in plasma. So that means that also the second criteria is met. As stressed, we have the possibility to use a capillary, so finger stick sample, which I think is an important feature for a point of care test. And obviously you want to have the confidence that you can use that sample type just as well as a venous whole blood or plasma sample type. So here you see the method comparison, the correlation. You see that the slope and the correlation both are for all sample types are very close to 1. And also if we zoom in on the lower range between whole blood and capillary samples, you see that the correlation holds up very well. So also in that area where your cutoffs are, the correlation is still good. More importantly maybe is the clinical performance, and this has been published by Gonzalez recently. So what they've done is they compared the Italica VTLI using the 99 percentiles to the Italica IM lab solution and the Abbott Argitect lab solution. And if you glance over the columns of sensitivity, specificity, PPV and MPV, you will notice that the values for the three systems are actually quite comparable. And that's also why the authors concluded that VTLI demonstrates comparable diagnostics as compared to central lab solutions. So in short, and to summarize, we have published articles that we meet the designation of high sensitivity troponin assay. There's a study done in Saint-Antoine in Paris where they have looked at a method comparison between Italica VTLI and Italica IM, showing good correlation and also receiving very positive user feedback from ED physicians and nurses. We have a study where we show the equivalence between the different sample types and also that there's comparable diagnostic performance if you compare VTLI to the lab. And what's very important to note here is that we have measured in whole blood, and that's also something that some of the guidelines stress, because whole blood is the relevant sample type for a point of care solution. So not plasma, but whole blood data is what's required. The future, I think, is quite exciting because the derivation validation setup has been done on a single rule-out for Italica VTLI, which I think is very important for this particular solution. And also a derivation validation of a 0-1 hour and a 0-2 hour rapid algorithm as outlined by the EC guidelines will be conducted. So we hope to be publishing on that also very soon. With that, thank you very much for your attention.
So Niels, thank you for highlighting the enormous progress that has been made now with this point of care option, and I was very happy to see that you have the work already lined up in order to do the next step, which of course is necessary to get competitive with the current standard of care in Europe, where using a 0-1 or 0-2 hour algorithm is the standard of care with one of the established assays. So congratulations for these major achievements. Questions, please. Alex, please.
Yeah, really bravo, because this is totally expected since many, many years, and now you achieved it. What was the difficulty to achieve this point of care measurement? Was it because of the whole blood? Was it because you needed to have a small point of care? What was really the challenge?
That's a very good question. So, as I said, I was part of the Philips team, and when I speak to the researchers back in the Philips days, I think they had some difficulties with the magnetic beads and the coating of the antibodies, as well as some of the aspects of the optics. So in the end, those things were optimized, and back in the days when I was still part of Philips, they were already very close to getting a high sensitivity troponin assay, but Philips didn't have the, let's say, the focus or the strategic relevance to prolong the investment. So I'm very happy that they could do that with a private equity behind it and then being acquired by Siemens.
Richard, please.
No, thank you. I have a practical question. Correct me if I'm wrong, but the point of care would, I think, be very valuable in ED, but my understanding is the 99th percentile, the actual number, is different than the Siemens lab number in the lab. So now in the ED, you're going to be ruling out somebody with a troponin that's high sensitivity, but yet with the same company has two different cut points. Is it ever possible to get the same cut points on the point of care? Because otherwise, I mean, I think it could get very confusing. You know, you have one in the ER and then one measured in the hospital, and that's on a different machine, and it has different numbers. And I just see that there could be some confusion here.
Yeah, absolutely. So if we picture a perfect future, then we would like to align the systems. So a little bit why it is different. We use different antibodies and the technology is different. So we have contemplated on using the same antibodies, but then still the technology would likely lead to differences. And as you know, it's not a standardized assay troponin. that being said, I think there are very interesting projects, for instance, from Professor Mills and Professor Blankenberg, where we look at finding, let's say, risk-based artificial intelligence algorithms, which turn these absolute values into things that you can compare with each other. And I think that's the future. That's where we need to be heading to. But for now, indeed, I think education is very important, and it depends on the preferences of a hospital. So, for instance, you could use point of care only to do the triaging, exclude that low-risk population, which is quite significant, and then maybe follow up the rest with the lab. But yeah, it's definitely not ideal, but I think that's reality for all of us.
Frank, please.
I don't need a microphone. Richard. So I know I'm not supposed to ask questions of the audience, but I'm going to ask this one for you. Richard, do you think that the cut points for point of care and lab-based troponin are the same now? The answer is no. And if that's the case, this is just a better way to skin a cat than we currently do, but no cut point differences. We'll still have differences between the lab and this point of care. Nobody has ever solved that problem. It should not be a reason to slow down point of care.
Yeah, one last question probably is important, the pre-analytical error. We know very well that in the confusion of emergency department, the troponin assay should be influenced by the way that you are taking the blood, and especially with this finger stick, the possibility of hemolysis is there. Do you, because they say that if you send to central lab, they analyze for hemolysis, it affecting troponin, and so do you have this question solved in pre-analytical issue from finger stick that should be influenced the hemolysis?
Yeah, so we have actually looked at the interference of hemolysis, and the beauty of our system is that it is based on the scattering of light. So the magnetic beads will absorb the light source, and therefore it's not dependent on color changes. And that's the theoretical explanation, but also in practice we have seen that hemolyzed samples do not impact our system. So yeah, I think we have an answer to that.
Okay, excellent. Thank you very much, Niels.